B asked to find the angle when the area is 12 root 3 meters squared. So what we do is make the equation 16 sine theta times 1 plus cos theta equal to that area, because that's the area function. And then we can solve this area function, and we're going to just make it equal to 0. Now, because this is cos and sine, it's really hard to solve this because there's no identities here that we can really use. So we have to rely on solving this by graphing. So if I graph this, this is what it looks like when I graph this equation here. Okay, so when I graph this equation here, so just to explain what's happened here, I've made this equal to 12 root 3. I've divided both sides by 16, simplified the fraction to 3 over 4, so 12 over 16 becomes 3 over 4, and I just move that 3 root 3 over 4 to the other side. Okay, so graphing that, I get this expression here, and I can see that the solution is going to be at pi over 3. So the angle theta is pi over 3. So theta equals pi over 3. So we can get that by graphing. Now, we could also get this, since it asks for exact area, what we can do is we can do this by some analysis. So since it's exact value, we know that it's a special angle. Okay, so it has to be either 30, 60, or 45 degrees. So because it's a special angle, if we take a look at this, we have a product sine, the sine ratio times the cosine ratio is going to give us a denominator of 4. So it must, the sine and cos must have denominator of 2. Okay, so because they're going to share, since it's a special angle and it's a related triangle, they're going to share the same denominator, and the denominator must be 2 to get this denominator of 4. So if it has a denominator of 2, okay, we then can say that it's got to be a pi over 6 or pi over 3 angle. And we know that also that this angle, because of the nature of the problem, must be less than 90. So it's got to be between 0 and 90 degrees, or 0 and 2 pi. Therefore, we don't have to worry about all the other angles. We can just test these angles. And when we test these angles, we can see that by just testing 2 angles, we can determine that that is our solution, which is pi over 3. And again, there's no direct solution to this algebraically, but we can narrow down our solution by some analysis, and we can then leave us with just 2 numbers to guess. For part C, it says the angle in part B, so pi over 3, is the maximum area for this deck, and we can prove this just by graphing this. So if I graph this, this is my function y equals 16 sine theta 1 plus cos theta. Okay, that's my area function, and we can see that the maximum occurs at that point. And if we go down, that point there is at pi over 3, so we can deduce that this is the maximum value by using some technology and graphing it. Same with B, we needed some technology to solve this as well. So when we end up with this equation here, we'd have to graph it to get the solution, and the solution was pi over 3.